Hello, everyone. Welcome to our lecture on analog electronic technology. Field effect transistors were developed on the basis of bipolar junction transistors and, like bipolar junction transistors, serve to amplify signals. However, whereas a bipolar junction transistor controls its output by varying current, a field effect transistor controls its output by the input voltage, and it is characterized by high input impedance and low noise. Both devices have 3 terminals with a direct correspondence between their electrodes. The gate, source, and drain of a field effect transistor correspond respectively to the base, emitter, and collector of a bipolar junction transistor. Although their package sizes are very similar, they differ in material composition, operating principles, and methods of use. Next, we will compare field effect transistors with bipolar junction transistors in detail. In Table 1, we draw an analogy between the 2 transistor types in terms of their electrodes, internal structure, key characteristics, and operating principles. From the table, it is clear that field effect transistors and bipolar junction transistors still exhibit many differences despite their functional similarities. Field effect transistors offer higher input resistance and simpler fabrication processes than bipolar junction transistors. Consequently, field effect transistors consume less power, maintain better thermal stability, and exhibit lower noise figures, making them widely used in large-scale and very large-scale integrated circuits. The following diagram shows a typical field effect transistor common source amplifier configuration by applying a fixed voltage between the gate and source, and then varying or adjusting the E sub Gs. The I sub D changes accordingly. This variation in drain current produces a corresponding change in the output voltage, achieving inverting voltage amplification. Thus, although field effect transistor amplifier circuits and bipolar junction transistor amplifier circuits are very similar, what further similarities and differences exist between them? We once again compare the structures and analysis methods of bipolar junction transistor amplifier circuits and field effect transistor amplifier circuits. Both circuit types share the same composition principle, combining AC and DC paths. The static bias network ensures that the transistor operates in its active amplification region, while the AC coupling network provides a path for the alternating signal component. Their analysis methods are also identical. Static analysis can employ analytical or graphical methods, and dynamic analysis uses the small signal equivalent circuit approach. Because of their differing structural characteristics, field effect transistors and bipolar junction transistors have different low-frequency small signal models. In the input loop, a bipolar junction transistor's base input current I sub B is small, and its equivalent resistance between base and emitter, R sub B E, is on the order of 1 k omega. By contrast, a field effect transistor's gate is insulated, so its gate current I sub G is effectively 0 and the gate source path is open. In the output loop, a bipolar junction transistor behaves as a current-controlled current source, while a field effect transistor behaves as a voltage-controlled current source. The 3 field effect transistor amplifier configurations, common source, common drain, and common gate, correspond respectively to the 3 bipolar junction transistor configurations, common emitter, common collector, and common base. In terms of performance metrics, field effect transistor amplifier circuits and bipolar junction transistor amplifier circuits share some similarities, but also exhibit differences. For example, the gain of the common source configuration is generally weaker than that of the common emitter configuration, with a voltage gain on the order of only 10. That concludes our discussion of this topic. Thank you and goodbye.